Okay, this is my Arduino alarm system. Now, the way everything works is I have 3 separate passwords set to 3 different rooms. Once you enter a correct password, the alarm is enabled. Any motion detected after that will go ahead and set off the alarm. The alarm sound is a recording saved on the MP3 shield. It's going to continue to play on loop until we enter the correct disable code. And as far as the interface goes, I have a green LED, red LED. The green one's going to turn on throughout the calibration time, and when we enter the correct password, the red one will turn on when the alarm is going off and if we enter an incorrect password. Also, there's an LCD screen and a keypad, and everything is held together with the Arduino Uno. Now we'll go ahead and demo a few different situations, and I'll explain how everything works afterwards. Incorrect code. Room 2 alarm activated. Now in the code, the PIR sensor takes 30 seconds to calibrate, but for the sake of the video's time length, I just went ahead and took that portion out. Alarm disabled. Room 3 alarm activated. Alarm disabled. Okay, that sums up how everything works. This is the schematic that we'll be using. I'm also going to show you guys a list of parts that we need and how to put everything together. Okay, so what we're going to need is an Arduino Uno with some breadboards, an MP3 shield, LCD screen, keypad, PIR sensor, diodes, resistors, green and red LEDs, a 595 shift register, an NPN transistor, and a potentiometer, and a bunch of wires. Now, the cool thing about this setup is that we'll only be using 3 wires that go into the Arduino instead of the normal 6 to 7 that come from the LCD screen. And this is all done using the 595 shift register with the Shift LCD library. Next, the potentiometer will go ahead and control the contrast, and after everything is set up, we can go ahead and run a quick test sketch to see if everything is hooked up properly. Sometimes when you start everything up, you'll see that there's a screen full of black boxes. That just means you have to adjust the contrast. Okay, now for the keypad. We're going to be taking the 8 pins that we would usually use and turn it into one through a voltage divider. We'll be hooking up different resistance for the rows and columns and have the Arduino read it as an analog value. Now, this may take up a little while to set up properly if you don't have the same exact resistors as I do. For me, it was a matter of trial and error because the goal was to get each keypad button to output a unique value and be at least 5 value points away from each other. I used a sketch that displays the analog value to the serial monitor, and I would just record what each button would value at every time I pressed it. The problem was, though, that I would have 2 different numbers given almost the same value, maybe 1 or 2 numbers apart. I would have to rearrange the resistors by adding more or using less until each keypad button was giving out its own value at a reasonable distance from the other numbers. I'm using the Phi interface library for this, and it has a leeway of 10, I believe, but you can edit the code to however you want it. I have the leeway set as 5 up and down from the value. I would also suggest running the keypad value sketch after everything is hooked up because I noticed that the values were different when I had the keypad connected alone versus when I had the keypad and all the other final components together. Next, make sure you have all the rails grounded and powered up, and then you can go ahead and connect the PIR sensor. Also, while you're hooking up your LEDs, remember to put a resistor in front of the positive side, the anodes, and then you can go ahead and connect them to the Arduino. Now, this is a look at the keypad value sketch. What I would do is hold down 1, find the most recurring value, write it down, and do this for every button on the keypad. Afterwards, I would double check to see if any of the outputs were overlapping. As long as everything was good, I would transfer all the values to this section of the sketch according to the character mapping. Now, the last thing to look into is setting up the micro SD card. This is how yours should look like. It needs to have the patch files on the root folder, and the MP3 files need to be formatted in the way you see it here. It must say track 001, track 002 in order for the MP3 shield to read it. Now that everything is done, you can go ahead and upload the final sketch and start demoing your new Arduino alarm system.